Okay, so now let's take the example of 2x squared plus 7x plus 3. And actually, before getting into that, I want to make a distinction because in the last part I was actually talking about simplifying a quadratic expression, factoring it, but not actually solving for x. And I would recommend you check our intro on quadratics to specifically know this distinction between quadratic expression, and equation and when you need to solve for x. But in this case, well, now I'm going to do precisely what you're usually going to have to do, which is solving for x. Okay, I'm going to do the whole process. There was just the last step that I had to do, but I forgot. So now, let's solve this one. 2x squared plus 7x plus 3 equals 0. So equals 0, again, the mindset here, if you want to solve for x, is that you want to make, well, not going to get into that. Check in the other video. Then, let's follow our steps. First, the sums and products. And now, we have something very special here, which we call leading coefficient. You can say a term as well if you consider the formula ax squared. If you consider the formula ax squared plus bx plus c, right? Then this is your a term. Sometimes your teacher will refer to it as that. But in any case, it's the number that's being multiplied to x squared, and this matters when you're splitting the middle term, when you're solving a quadratic, because now you can't just take two numbers that multiply to this one and add up to this one, because now this does affect your answer. And what you need to do is, instead of just something product to this, you need to find two numbers that add up to this term and then multiply to this one times this one. Sorry, that is a multiplication, not an x, okay? Times that one, okay? And I'll show how that works. So, so we want to have two numbers that add up to 7 and multiply to 2 times 3, which is 6. Two numbers that add up to 7 and multiply to 6, okay? Then again, we can break down by going through the numbers that multiply to give you 6. So in 6, we can get 3 times 2, right? And in this case, they're both always going to be positive. Oh, actually not. They could be both negative. We could also have -2 times -3 to give you 6, right? Because negative times negative equals positive. Then we can also have 1 times 6 and -1 times -6. Now we can add these. Oops, sorry. This now becomes addition. Should be addition. And we find the sums of each of these two numbers to see which of them are also adding up to 7. So 2 plus 3 is 5. Is that the sum we want? Nope. -2 minus 3 is -5. Is that the sum we want? No. And 1 plus 6 equals 7, and that is the sum we want. So we now have our two numbers. Okay? And if you skipped to the part of just, writing the final factors with these two as x plus 1 and x plus 6, this will not work so simply, because then if you try multiplying these back, you're going to see you're not going to get this equation. You're not going to get this expression. So that does not work anymore. Now you have to go through all this splitting the term shenanigans. Okay, then let's go through our steps. Second, splits the x term. So now our 7 instead of 7 is going to be 6x, oops, plus here, plus 1x, right? Which is exactly the same thing. 6x plus 1x gives you 7x plus 3. And let's leave the equals 0 here. Now we group these into two separate parts, which is the reason why we separated them. We wanted to group them in different ways. This one here disappears. I mean, you can write it, but it doesn't matter because 1 times x equals x. And these are your two groups. Now you look at how to factor each parenthesis. First one, what can we factor out? Well, let's do our breaking down of multiplication. 2x squared is 2 times x, times x, plus, and then this is 2 times 3 times x, correct? So in this case, we actually have 2 repeated multiplied values in each added, part. So we can actually pull both of those out from a parenthesis, which will give us 2x times x, and then what's left is this x and this 3, x plus 3. Then, let's go to another parenthesis. In this case, there isn't really another way to, break these down into multiplications. And is there anything you can divide x by and also divide 3 by? Not really, in this case. So, the number you factor out will actually be just 1. Sometimes this is exactly how it works. And for you to know if you did the right factoring, you need to see if these two parentheses are equal. And in this case, since they are equal, then you're good. If they're not equal, then you need to go back and see if there's a different way you can factor. Sometimes there are different ways you can factor that will give you different parentheses, but ideally you want to look for what you can factor that will give you the same parentheses, okay? Now, last step is to factor finally. So since we have x plus 3 multiplied to these two, we can bring it outside and rewrite this as 2x plus 1, that's a 1, times x plus 3. You see, brought these two outside. And this is our final factored form. And if you're curious to see if this is right, you can multiply, do the FOIL back to see if you really get this quadratic. Because again, you're not changing the quadratic yet, you're only rewriting it in a factored form. So we can solve our equation. So now we get to our last step, which is solving for x. So if we consider that this factored quadratic is equal to 0, then we know that when this parenthesis is 0, the whole thing is true, right? Because if this parenthesis is 0, the whole side will be 0, which will make this true. If this parenthesis is 0, the whole side will be 0, which will make this equation also true. So we bring it here, find what makes x plus 3 0. For which x will x plus 3 be 0? And this we can solve actually as a normal equation, subtracting 3 to the other side and giving us -3. Then we do the same for the other factor, 2x plus 1 equals 0. And again, solving it like a normal equation, starting by subtracting the 1's, because we have a video on solving equations as well. Check that out. Then multiply by 2 gives us x equals -1/2, right? And these are our two answers for x in this quadratic equation, okay? So when you're solving for quadratics and you see a quadratic that has this beginning a term, leading coefficient, whatever, when you see there's a 2 or a number before the x squared, you can't just use sums and products. And if there was nothing here, I would just use sums and products. It's just much easier. Then, if not, use splitting the middle term or quadratic formula. Again, it's up to your decision. Just giving you the strategies, but you choose which one you are better with, which one you're more comfortable with. Okay? Thank you very much. Any questions, you can send us an email, and make sure to check out the more other videos in this series where we explain further quadratics, different methods, and get into functions later as well. See you.